Dear students, welcome and thank you for tuning in. We are continuing our discussion about design for environment. In this video, we are going to talk about the Cradle to Cradle and the life cycles. Cradle to Cradle is a design for environment method emphasizing renewable resources and sustainable life cycles. This was presented in a book made by William McDonough and Michael Brangart. They are the founders of the McDonough and Brangart Design Chemistry Company that Herman Miller teamed up with in order to come up with their design for an environment methodology assessment and setup. They created this book published in 2002. It has a lot of ideas about how to remake the way we make things in order to be more environmentally friendly and to reduce the environmental footprint. This company, the McDonough and Brangart Design Chemistry, works with a lot of companies to select the safest material for design. Remember, we talked about the two challenges, that material and the other one is energy. We are focusing on the material side of things. In this Cradle to Cradle concept, the idea was revolving around the concept of cycles. We will look at any product life cycle. So you will start with the material, raw materials, you get the materials and you produce your product, you distribute it, and the user, they're going to use it. And we have this open loop. After it's been used, it will be dumped, it will be thrown away into the garbage, and nothing's going to happen for that product. So we need something to close the loop. If we want to look to be mimicking the natural life cycle of things and to assure sustainability. So we need to have good ways of disposing the products, and then in such a way that they will go back as a material to be inside our cycle again in the production, distribution, use, disposal, material, and so forth and so on. So this is what we call the product life cycle. Now, we need to have something called life cycle assessment. And this is a way to quantify the environmental impact of over period product life cycles. And there are steps that we need to take in order to assure that we are, assessing the life cycle of our product. And in the product design development process, we would like to do this. You need to do this along the way in all the stages or the steps. But we are, explaining it now because we have a good idea about our technical aspects, and now it's the time to look into the impact on the environment and also how can we improve our product and the appeal of the product and also the footprint of the product. So the steps in this assessment, if you want to assess if our product is actually environmentally friendly or not. So you need to prepare proposed design options. We did that. You have a lot of concepts and you've tested those concepts and you've selected one of those concepts. So we have the design options. We have our design, right? And we need to put some options for this design. Then we need to identify the life cycle of our product, including the recycling and disposal. So as engineers, if we are designing a product, our job does not end in just manufacturing. We need to identify the life cycle of this product. How is it going to be disposed, and is it going to be recycled or not? Then we need to identify all the materials and energy sources used in manufacturing, in distribution, and also in use as well. You need to have, let's say, energy saving products. You don't have products that they consume a lot of energy. And also you need to identify outputs and waste streams for your product or the components of your product. So if you have a product that uses a lithium battery, how is that lithium battery going to be disposed? You need to have an idea about this and make it clear for the customers. Quantify impacts of each material, energy, and waste. How is it compared to other competitors, and what is the impact on the environment will be? And we need to aggregate impact into categories for comparison. So all these steps, the product design development team need to take to do and write about in their design and the documentation that they're creating to make sure that we are assessing our environmental footprint. So in order to do this, there are some softwares, and you need training, and you need experts in this field. So it will be great if we have one of the team members who are actually in the life cycle assessment of products and the integration with the natural life cycle. Some of those life cycle assessment softwares are listed here. So SEMA Pro, Gabi, and OpenLCA, and Sustainable Minds. So there's a lot of sources and softwares. It's worth actually checking and seeing if you want to utilize them and or to use them. So in as long we are talking about cycles, and this is the integration of a natural life cycle with a product life cycle. So the one cycle to the left that has the green, this is the natural life cycle, and the one to the right is the product life cycle. And the ideal situation is that you need to have these two cycles integrated together in order to continue having sustainability, and so that we are producing products that they have the least amount of footprints on the environment. So if you look at the left cycle, you have, you start from the resources, it goes to a material, and then the material enters into the other cycle where it's production, distribution, use, and then recovery. And those are the arrows in green and blue. Now, after the use, you have the recovery. So you need to make a decision what's going to happen. So if you're disposing it in nature, again, it has to be disposed if you are following the brown arrow. Now, disposed into the natural life cycle in order to go to the resources and then recycle to be used as a material. Or you can do remanufacturing, reuse the product if it's not, if you can fix it and it's still functioning, and post customer recycling. So if you bought a product, we talked about some examples that like the boot. So people will get their product again, then they will enter in the recycling stream within them. So this is the ideal situation of an integration between the natural life cycle and the product life cycle. Now, where are the challenges? The challenges lies in three places. The first thing is that our resources, we have non-renewable resources. So that's a big challenge, and we need to be creative and innovative about what kind of, especially when it comes to energy, what kind of resources we need to use. That's from an energy point of view, and using to solar energy, wind energy, thermal energy, and geothermal energy. And from the material point of view is that we would like to make sure that we are not depleting the metals, the inorganic metals, and also we are not, collecting them and dumping them into landfills and to create unnatural concentration of metals and toxins. Number two is inorganic compounds. So if you're using plastics, they are inorganic, and when they are after use and they will we can't recover them, and they are being deposited in nature and they don't degrade. And this is a huge challenge from a material point of view. The third challenge is toxic materials, which comes as byproduct of burning materials, or if you are from ashes, or so, and the CO2 and fossil fuel consumption. So these three challenges are very, very important. And if we are designing our products, we need to at least address what's the impact of our product or components of our products on nature regarding to these three challenges. So to summarize, what are the conditions of sustainability in order to sustain this beautiful ideal integration between the natural and the product life cycle? We need to keep in mind that Earth is a closed system, has limited solar input and natural biocycles. Solar energy and other renewable fuels are sustainable energy sources. So from this energy point of view or side of the challenge, we need to make sure that we are using renewable energy, sustainable energy, not depending on fossil fuel or non-renewable types of energy. On the material side of view, so the resources must be balanced with the rate the resources use must be balanced with the rate the Earth creates each resource. Even if it's the fossil fuel, we need to balance this. We cannot keep consuming fossil fuel until it becomes zero. And also toxic materials, heavy metals, radiation, and other molecular garbage that it is not part of the natural life cycle must be eliminated, because they don't belong, and we need to find innovative and creative ways of eliminating those materials. Thank you for watching. Until the next video. Bye.